Okay, so now we're ready for the next speaker, which is Filina. Hi, Hannah, welcome.
Hello.
Hope you're fine. You're reaching us from Canada, if I'm not mistaken?
Yes, Canada.
So it's
it
morning.
It is now early in the morning, yes. And I have construction work outside my house, so it's going to be fun.
Oh, we're not hearing anything, so it should be fine. So you're another long-time developer, like Enrico, since 1997, if I'm not mistaken. And I think you're kind of famous because you're like to dabble with legacy software. If I'm truthful, I follow you on Twitter because of that. You tweet a lot of funny stuff about that. This is also the topic of your presentation, right?
Exactly. So I'm talking about how to tackle legacy code rewrites, and I'm going to be talking about various strategies that you can employ for that.
Great. That's a very interesting topic. So the stage is all yours. Let's share your screen and go on.
Okay. So let me manage all my windows. All right. So let's talk about legacy code. So the reason I chose this image is because this is what code likes to do when it's been unmaintained for very long. It just blows up in your face. So my name is Filina. I've been presented already. I've been coding since '97. I do legacy archaeology, which means that I dig into some really old code that's hard to understand. So you don't have to. And I also love test automation. I give talks and workshops. I tweet out some advice. I also sometimes tweet out funny stuff about legacy. I try to be nice towards legacy. And I also make some YouTube videos, although I'm pretty much long overdue for my next video, so hopefully that will come out soon. So the thing is, when I work with legacy, I don't work on a single project. I work on a whole lot of projects for other companies. So I see roughly 20 legacy applications per year. That's not counting advice gigs. So 20 legacy applications in which I actually put my hands, I get my hands dirty with them. So let's get right into it. Let's say you inherited a 10-year-old code base, or maybe it's 15 years old, maybe even 20 years old. So that means that code that you're dealing with now has been written around 2000. And what was the web like in 2000? Well, it was 600 pixels wide. So this is Yahoo from back in 2000. If my profile photo for this conference was that small, it would probably be rejected. It doesn't have enough pixels. What else was happening since 2000? So just to give you a timeline to understand why some decisions were made. Well, if you say, well, this code doesn't have unit tests, well, PHP unit only appeared in 2001. And it took some time for it to get some traction. So people weren't really writing many tests in PHP back then. Then in 2004, we finally had PHP 5 come out, which means that any code written before that is probably running on PHP 4. So it doesn't have a lot of the features you were hoping for. In 2005, the Symfony framework came out. So this is not the Symfony framework that you know today. Symfony 1 was substantially different. I like to think of it as a draft for what we have today. So before that, we didn't even, we did have a few frameworks, but none that really stuck as much as Symfony. In 2006, we had the first version of Zen framework. So these two came out pretty close together. Most of the applications that I migrate have been written in Zen framework. So they really popularized frameworks and everybody rushed to create applications using that. So it was pretty much like a golden age of applications since then. So everybody had a web application for everything. And now all of that is legacy code because it doesn't fit with any of the modern frameworks. In 2008, the book about clean code came out. And that doesn't mean that clean code was not a thing. People have been writing books about good code since the 60s. But really, especially in the web, there was really no conversation about it, what it means to have clean code. So it is very likely that code written before that time wasn't very clean. And even still sometimes today, because there are always new people who come into the industry and they don't necessarily know how to write clean code, and that's fine. That's why we're here to teach them. So Laravel, the first version came out in 2011. So that's a long time ago, which means that there are plenty of Laravel applications right now that are considered legacy, and I have been dealing with many of them in the past. So this is your timeline. So your code was written somewhere on this timeline. So you can imagine that it wasn't following today's expected standards. Because if it came out in 2003, then it's probably PHP 4. So you cannot migrate it to whatever framework you want. So there are many steps you have to do before you can put them on a framework. So what I want to share today are, just how to deal with legacy code in general, some stories and advice. I cannot do a complete talk and tell you exactly how to deal with every single problem you might have. That's enough to fill several books. But I will share some strategies with you. So first, let's talk about the things that make me sad in legacy code. It's not an exhaustive list, but things that when I look at them, I know exactly what I'm going to be dealing with. So the methods can very easily exceed 1,000 lines. And it just goes on, and there's nested ifs everywhere. So every time there's an exception to some use case, people are just going to add another if, and it just keeps growing over time. And you have these generally fat controllers, if there is a framework at all. If there's no framework, it's even harder. Sometimes there are even no objects because the code was written in PHP 4. Even though objects were supported, it was limited, and most people didn't write objects back then. Also, the methods can mix SQL, PHP, and HTML. And it's just not just inside the methods. You can still have an MVC framework and still be able to run PHP or execute SQL inside the view. So you can just call the database wherever you like, because essentially the views are PHP code with HTML sprinkled in. So that's a bit of a problem, because then you mix all of these concerns together. You can have methods that receive dozens of arguments, and those arguments can be of arbitrary type. Not just they can be any type, but each individual argument can be at any point in time either an array, a string, a null, a boolean, generally a false. So you have to check for all that inside of your method to make sure you don't blow up. Especially once you start upgrading to newer PHP versions, those things become more important. So older PHP versions tend to be a bit more permissive in terms of types, but with newer ones, you have to be extra careful. Then you also have methods that access hundreds of potentially undefined properties within an object, because sometimes people would set them dynamically. So one method would set a property and another one will access, but if you call things in a different order, then suddenly you have undefined properties. So the code is going to blow up. You also can have you can also have a method that expects a property to be set, but it has been set maybe 10 children down. So you have a class that extends, a class extends, and then somewhere there a property has been set. But if at any point in time you decide to let go of certain children, maybe you rearrange things a bit, or if you want to reuse that code somewhere, suddenly it's no longer possible because things are far too removed. And also it makes it very hard to understand what's happening in the code, because you have to open all of these 10 parents or children, and you have to sort of see everything at once in order to figure out what's happening. So it can be a bit messy. It's not always messy, but legacy code tends to be like that very often. You also have code that has been added and the previous one has not been cleaned up. So just instead of editing an existing code, an existing method, let's just add a new method called new, and then new2. And then the other ones are maybe dead code, maybe not, we don't know. Some places might still refer to the old method, and that's when you can get into trouble, when you start fixing things. So in addition to method problems, dynamic types are both the advantage of PHP, but also some of its biggest drawbacks, because if you don't check things very thoroughly, then you can end up with null pointer exceptions of every flavor. So things are just going to blow up because a property doesn't exist, a method doesn't exist, something is null, and you cannot call a method on a null. So it's very difficult to debug. You can also end up concatenating things that are not strings, like you would expect an argument to come in as a string, but maybe it's a null or a false or an array or the actual object that doesn't have a toString implementation. So it will blow up. It might not blow up on older versions of PHP. It's just going to be silently ignored. So you might have plenty of bugs in there that get silently ignored. But then when you upgrade to a newer PHP version, things are going to start blowing up. You can also attempt to split an array, again, doing a string operation on a non-string. You can divide by null. So that's not even division by 0. This is division by a null. It's another whole nother level. You can also count the number of elements in a float, so or even a null. Like you attempt to count things, but it has never been set because everything is dynamic and unchecked. Also, and this is something that I stumbled upon really by chance, is you can actually I don't know how to what extent you can do that in newer versions of PHP, but you could stick pretty much anything into the max method. You can even stick arrays, and those arrays can have items that are not all of the same type, and it would yield the result. And it's apparently possible. And I'm not going to tell you everything that is possible with Max, but have fun experimenting with it. Yeah, it's going to blow your mind. You can even put an exception into as one of the arguments for the Max method, and then you will have a maximum exception. If you want, I have on my Twitter profile, I have a pinned thread where I sort of just, whenever I stumble upon interesting stuff, I just put it there and I propose solutions. So it can be entertainment, but also a good learning opportunity if you want to see the kind of horrors I see in legacy code. So before we start a rewrite, we have to understand how to not do a rewrite. Because people think that if only they were given the chance, if only they had the budget and the time, they would rewrite everything and it's just going to work out fine. But the problem is that, unfortunately, rewrites very often fail for various reasons. I'm not going to go too much in depth of all the reasons, but sometimes projects even fail multiple rewrites. So I had this with one client where they were already on their third rewrite, and I already saw all the places where things are going to fail, and I was warning them about that. And this is despite budgets of millions of dollars. So it's not because they don't have the budget, it's not because they don't have the time or skilled people. People were skilled as well, but there are always ways to fail a rewrite because it's such a big task. And one of the big reasons I find is people become too ambitious. They say, well, if we're going to, apologies for this. I'm sure I turned it off. All right, so they start with an ambitious new stack. They say, well, since we're going to do an upgrade, we might as well, do some microservices because we read that monolithic applications are no good, so we should split them up. But also, we're going to switch to a different framework right now. We're also going to use Docker. We're going to use Ansible for our deployments. We're going to use Elasticsearch, which is a great tool in itself, but you have to be careful not to do too much at once. Then we're going to host things on AWS, and we'll also switch from our SVN server to GitHub, and we're also going to use Circle CI, which we never used before. Circle CI is for for CIs like Travis or GitHub Actions. And we'll also separate the backend from the front end, and we're going to use Flutter. So these are all amazing technologies, and you should probably use them. But the thing is, sometimes you set out to solve a very specific problem, and you end up doing too much at once. And the problem with this is that your team doesn't necessarily know how to write microservices. Your team doesn't necessarily know how Symfony 5 works. So if they're going to write something on top of that, they might end up in a situation where they're not using it right. So it ends up not being the most optimal code. So with all these new technologies, what happens is you might not have any experience with that. And so when things blow up, you have too many things to debug. Like if something happens within Docker and you're not good enough with Docker, and you don't have somebody on your team dedicated for that, for debugging those issues, then you're always going to have to, halt your development and then deal with that problem, spend possibly several days debugging an issue, and then get back to your code and kind of lose the context where you were. So you're going to have very little progress, and you're just going to be lost in all of these technologies. So it's important to limit the scope, both in terms of how many features you're going to rewrite, and also not go for an ambitious new stack, especially if you're not familiar with this. If you know all of these things inside out because you've worked with them before, you have somebody on the team for every single one of those, then that's fine. But if you don't have enough familiarity, you have to be careful. So the first thing you have to do before you start writing or designing, you have to start with a strategy. So which approach are you going to be using for rewriting your code? And so yes, cracks, in your bricks are ugly, but it doesn't necessarily mean that you have to rebuild the entire house. There are ways to redo or patch things that are actually going to be quite clean. Because sometimes, very often, I open up legacy and people say, well, it's a total disaster. And I open up the legacy and I say, well, this thing has been done right, and this is good, and this is like very well organized and standardized. So there's actually a lot we can do with it. It's not even about salvaging. It's that the code is actually not too bad. It's just that it relies on some old patterns or some old technologies, some old frameworks maybe. So I have 5 major strategies that I employ for migrations. So sometimes I would just upgrade the version of the programming language. So let's say we're going to go from PHP 5.3 to PHP 7.4 or PHP 8 now. So we're just going to upgrade the version and make sure everything runs smoothly. And then maybe as a second step, we can switch to a new framework. Because if you try to do everything at once, again, it's too ambitious. Maybe the scope is too big. And you're going to have too many things to debug when things don't behave the same as they used to in the old application. You also can do a progressive rewrite. You can also, so progressive rewrite means that you take individual components and you swap them out. Refactoring only, so you don't actually rewrite anything. You don't swap any components or frameworks. You just reorganize your code so that it's more maintainable. And then, of course, a full rewrite is still an option. It's just that it shouldn't be your default in your mind. It should always be the last option you consider when you've exhausted the other strategies. This is my opinion. Your opinion can vary based on the types of application you deal with, but I have applied all of these strategies in various situations. So when would you apply this or that? Let's say a version upgrade. So the way this works is you have an application that runs on PHP 5. And so you decide, well, you know that PHP 5 is end of life, has been for a very long time now, and you want to update to the latest version. So what you would do is you would make it run on PHP 8, and then you're going to see where it breaks and then create the appropriate patches. So you're going to fix the code to be compatible with PHP 8 in all the places where it's not, and then you're going to get rid of PHP 5. So that's the general idea. And so version upgrades are some of the easiest migrations, I would say, because you don't actually need to freeze any development. you can just keep upgrading your application while it still runs on an old version on the server. You don't have to be completely ready before you deploy it, because you can make changes that are compatible between both versions. And this is the most common migration that I do, where I make, so I had a client just this year, I finished a migration where they were on PHP 5.6 and we moved them to PHP 7.4, because at the time we started the migration, PHP 7.4 was still the latest. So we moved it to PHP 7.4, but that code was still compatible with PHP 5.6, so it could run the same on both versions. But the thing is, we were also testing it on a server in isolation with PHP 7. And when everything was working fine, we can then, the code which was already running in production, we could just go and swap out the PHP version underneath it. So just redeploy it to a new server. They had like a big server pool, and they would just roll out progressively the PHP 7 servers. So there is no freeze to development. PHP Code Sniffer, in case of version upgrades, is very, very useful, an amazing tool. It can detect incompatibilities between the version, between the code that you have and the target version to which you want to migrate. You have to understand that this is one tool. It's not perfect. So the way Code Sniffer works is, if there is something where PHP Code Sniffer is not sure, it would rather not flag it. So it tries not to give you false positives. So it's only going to flag it if it's absolutely sure. In some cases, it's going to tell you, well, you have to, at the very least, review this. But most of the times, it would rather not flag things. So it could miss things. And it also cannot detect certain things that are a bit more complex, where you can really only determine them at runtime. So it cannot detect everything. But it's a really good start. So I had a project which was about 4 million lines of code, and I had a code sniffer report that was something like, I think, 35,000 lines. So like there were a lot of incompatibilities. But luckily they were, divided into categories, so I could address one of them at a time and then commit. So when you upgrade to a new version, some people think, well, my application is only 200,000 lines of code. Well, you have to also consider the libraries and frameworks that you're using. If those libraries are not compatible, you may not be able to swap them out. Like swapping an ORM is no easy feat, because you have a completely new API for how to use this ORM, and the framework can also make substantial changes, require substantial changes to the code. So if you want, you can also swap those out, but then you're increasing the scope dramatically. What I usually do is I swap out the libs that are easy to swap out, and the others, I just make them compatible. Because, I mean, usually it's not that much of a big deal. It's just going to have things like it's using hexadecimal strings wrong, or it's using the each function, which has been deprecated in PHP 7 and then removed later on. So it's not really that big a deal and can be replaced fairly easily. The application code is usually the hardest part, but you still have to include the framework migration, the framework upgrade as part of the effort. So yeah, some libraries might be easier to swap out. So PHP Excel can be swapped with PHP Office, and it has very little, so PHP Office with the spreadsheets. So it has a very similar API, so it can be fixed fairly easily, even with regular expressions. You just go and you change a few things, and that's it. You don't have to do any substantial changes. So that's one less thing to that you have to upgrade yourself. Right. So yeah, regular expressions are your friends, but you have to be careful. First of all, they can break syntax or make mistakes, so don't rely on them like 100%. Apply like one regular expression, like make, I don't know how many substitutions, and then review the changes before you continue. So review the changes, make a commit, make a pull request, whatever, and then continue with the next regular expression. So always review what they have done. It's it's not a good idea to just leave it like that, because sometimes you might have actual syntax errors that are generated. Like, for example, you have trailing commas in places they shouldn't be and things like that. So your code wouldn't even parse. You can also use something like Rector or PHP Storm plugins. So Rector is written in PHP. PHP Storm custom plugins are written in Java. So you can write those to automatically refactor your code. So think of it as a script that automatically changes your code. And the way they work is they actually, they don't work using regular expressions. They work by creating a syntax tree. So like it knows that something is a method and the method has arguments and those arguments are of a certain type. So they can analyze your code and then you can use that information to make your own decision. You can say, well, if this method is called on a variable that is of this type, then change it to a different method call and maybe reorder the arguments. So you can make some pretty advanced changes. It has a bit of a steep learning curve, but if it's going to save you months of work, which it could very well on any given project, then it's a good idea to invest into learning those tools and mastering them. Because if you're like me and you do migrations pretty much all day long, then I've probably shaved off years of work just by automating things this way. So it was well worth the investment. So an example of what Rector would do. So this is PHP Excel being swapped out for PHP Office. Rector actually goes and it has already some written rules to be able to upgrade that. So you can just basically one-click upgrade your code to use the new library. You can do the same thing with regular expressions. It's a bit better with Rector. So this has been taken from the Rector website. And so I want to credit Thomas Vachuba, who has written the tool and created those examples for us. So it's a great tool. So this is an example of what in PHP Storm, what a custom plugin would look like. It would find things, it would flag them for you based on your own custom logic, and then you can write your own auto-fixers. So in this case, I was migrating from Doctrine 1 to Doctrine 2, where Doctrine 1 is active record, Doctrine 2 is a bit different. It uses entities and repositories separately. So I wrote something to sort of recreate the mapping from Doctrine 1 to Doctrine 2 with annotations and everything. So in this particular project, which is about 1 million lines of code, I had, I think, 500 something models, which if I had to do them by hand, that would have amounted to 1,000, so 1,000 classes. So 500 for the entities, 500 for the repositories, and I would have to do thousands of mappings, relationship mappings manually as well. So you can create basically very intelligent changes by the thousands using your own custom plugins. So this has been written in Java. So this is not like an open source project. This is an example. It's very specific to my use case. But it doesn't take that long to write. You just need to learn how to create PHP Storm plugins, and after that, it gets much easier. So for another type of migration, you can also swap out the framework. So let's say you have an application that is written on top of Zen Framework 1, and let's say you want to change it to Mezio. Well, when you port an application to a new framework, you might have to rearrange your code a little bit if it's very, very tightly coupled to the framework. So in Mezio, the changes are a lot more significant. And so when you rearrange things and port it to a new framework, some things are low-hanging fruit, like using a dependency injection, especially if you automate things with Rector or custom PHP Storm plugins. You can replace hard dependencies with dependency injection. So DI would be probably the best investment into future testability of your application. So it is one of those scope creeps that might be worth it. In my case, I always do that because it really, really saves a lot of effort later on. So you can automate large chunks again, because you can take a class that is written, for one framework, like a controllers mostly, and you can refactor them to use controllers refactor them to like Mezio controllers. They're called handlers, actually. I'll show you an example in a bit. Another thing that you can use when switching to a new framework is to use adapters. So what adapters do is, let's say you have, here's an example. Let's say you have this call within a Zen Framework 1 view, which is a PHTML file. So it's basically PHP, really, but it has HTML and a few PHP tags throughout. So you could say this submit button, and that will call a view helper called submit button, and then it will accept those two arguments. But let's say you're moving to a new framework that has either a different method name or maybe the arguments are in a different order. So instead of going in and changing thousands of views manually or even automatically, you can just use an adapter where you create something that wraps the new helper, the new view helper, but provides the submit button method the same way as the old one, so that you don't actually have to go and update all the views. You can just call it the same way, and it's a good first step in order to accelerate the transition to the new framework. Because remember, when you switch to the new framework, you would generally halt any new development. So you want to get this step over with as soon as possible. So yeah, you need to freeze developments. So here's an example of moving from Zen Framework 1 to Mezio. I have done several of those in the last few years. So let's say you have a product controller with an index action, a view action, and a few private methods that those two can call. So Mezio doesn't have one controller with several actions. Every action becomes its own class, which is called a handler. And so what I could do is then split this up into 3 different classes, one for each action, and then another one from which the other ones will extend, one parent class called base handler, which will have all of the private methods that you had, and then you're going to bump them up to protected. And so you can reuse that. Because you can always refactor it, but then you'll too significantly change the code, and it's going to be much harder to debug when you look at the old one. And also, I moved some of the framework-specific configurations like routes and other stuff, again, which can be automated either through regular expressions or Rect or PHP Storm. So I had this project where I had 300 different actions, and I migrated that, their routes and their permissions all automatically. I mean, it wasn't working immediately after that, but it did a lot of the heavy lifting for me, so I didn't have to do it manually. It would have been months of work just to do that by hand. For another project, I did the same for models. I migrated roughly 67,000 lines of code worth of models from one ORM to another. So yeah, use automation a lot. And then those transitions are too slow on this. So this is an example of what this handler might look like. You could have, instead of the index action, we would have the index handler, extends base handler, and in Mezio it has to implement the request handler interface. And then you'll have a constructor where you would use dependency injection. So because you're not extending from the framework controller, you cannot say this render. You're going to have to say this template render. So this again can be automated with scripting, and just create those classes and analyze the syntax, and just in the handle method, this is where the actual action is happening. You could just wrap the render in this template render, and then wrap this in the response, and then send it back. So the idea is, so when you looking at the code, you may want to keep the same variable names. So as tempting it is to rename things to something more meaningful, if you do too much renaming and moving around and refactoring, what will happen is when this handler misbehaves, so when you go to the browser and it doesn't behave the same way as the old one, you will have a much more difficult time when comparing to the old code. You wouldn't really know what is it you broke. So by keeping it as close as possible to the old one as a first step until you migrate everything to the new framework is a good idea. And then you can refactor. That could be like a completely different phase, and then you can rename to your heart's content. Yeah, and so when I do the migration, I don't start with automation. I first do like a proof of concept, because I always deal with like a different starting point and a different endpoint. Like sometimes I would migrate from Zen Framework 1 to Laminas, or I would migrate like from Propel to Doctrine, or maybe from Doctrine 1 to Aura. It can be so many different possibilities. So I don't know how exactly that's going to happen in advance. So what I do is I migrate a few controllers first manually, and I see what needs to be done. And once I finish that exploration, I have that proof of concept, then I can start automating it by following the same steps. So another approach is to have a progressive rewrite. A progressive rewrite is when you take a piece of the application, and then you rewrite just that piece, and then you plug it back in, right? So you take out a piece, you replace it with another one that is completely new code. So a progressive rewrite, usually I like to do it either by endpoint meaning as a URL, or a feature. Like I could take out entire feature, like something that calculates the prices, or taxes. I can take out that part and refactor it, and then put it back in and tie the parts of the application that point to it back together. So the reason I like it is because, especially with the endpoints, I can switch the language. I can have part of the application running on PHP 5, but the parts where I rewrote the endpoint to a new framework, for example, just one, not the entire application. And I can make the transition seamless between, so the user can be like logging into one application basically, but then for another endpoint, they're going to be transferred to a completely new application. But the thing is, they're still going to keep the same database. They're still going to keep the same session. So that for the browser, it's completely seamless. And then under the hood, it can be a different language version, and even a completely different language. So I did that as a progressive rewrite from ASP Classic, which has been dead for, I think, 15 years already. And so we were moving from ASP Classic to PHP 5 at the time, because that was the latest version. That was years ago. But yeah, you can completely switch the language under the hood. And one of the processes I like to use for progressive rewrite is to use design extraction. And the reason to do that is because I don't want to have the bias of the old code. So if you're staring at the old code, and if you write new code straight from the old code, you're going to inherit some of the flaws of that code, because you're going to be biased. What is a better approach is, and this is not my invention, you just take the code and you extract the design. So from the old code, you create the old design. Then you don't look at the code anymore. You just look at the design and you improve it, or you create a new design based on that design. And then what you end up with is basically a completely new set of requirements that you can go and implement. So at the time you reach the new design part, you can completely disregard the parts, the old parts, and you can just write the new code. You write the new endpoint or the new feature, and then you just plug it into your application. Another approach is to just do refactoring, which usually people don't ask me this upfront. They would rather first, move to a new framework, things like that. And then as another phase, you can do refactoring. So refactoring is to increase the quality, the testability of the code, its maintainability. So the way this works is very similar to a progressive rewrite, but you can take, for example, a class out of the application, and then you can, replace it with two other classes, because maybe you mix too many concerns. And so you can split things up. You can refactor in many different ways. You can refactor even at the method level and just split it up into smaller methods. So yeah, this one focuses more on improving the code design and structure. And it allows you, some of the techniques that you can use is, you can obviously remove that code to just get rid of methods and classes that are no longer used. You can move logic to a better location, because maybe things are just in some utility class that's like this giant class that has 1,000 utility functions, maybe you can encapsulate things better. You can also split long functions. And I mean, there are enough techniques to fill an entire book, and luckily there is one written by Martin Fowler that has all of these awesome techniques. So highly recommend this book. It's a lot of fun. So when you want to decide, when you're deciding to go for refactoring only or not, some of the criteria for that is, do you actually need to change that code? So I rarely go on a refactoring crusade. Like if I need to change the code, then I might as well refactor it before I make changes so that it is much easier to make the change that I want. And also if something is hard to understand, but I need to work with it, like I would refactor it and then I'm going to work with it. So it's a good opportunity when you actually touch it. Because the thing is, if you're going to spend so much time understanding a particularly bad piece of code, you might as well take that understanding and refactor to sort of capture that understanding in some better design code. So I usually refactor only for a purpose. I don't go like on refactoring sprees. Full rewrites, I mean, I discourage them. I don't say there's never a use case for that, but I really want people to see that as a last resort. So think of a full rewrite. Basically, you're writing a completely new application. So my criteria for picking this strategy is if I can disregard the existing features. Sometimes people tell me, well, we have this application, we want to refactor it, we want to improve it, but the thing is the way features currently work, it doesn't even make sense anymore. We would like to change that completely. So if you're not going to keep any of the existing features, then that is a good candidate for a full rewrite because you're going to write a completely new set of features. If it has few or no integrations with other parts or other applications in your company. So for example, I was working at a bank and they had this application where everybody was relying on this application to be there. And so if you remove it, then they wouldn't be able to plug into it. So it wasn't very easy to do that. We had to put a lot of effort to first dissociate, find all the places that use this application, which in a very large organization, it's not very obvious. Things are not documented as well as you think they are. Things can just start blowing up in production because somebody removed a dependency that you didn't even know was a dependency. But if it has few or no integrations, then it's a bit easier to do a full rewrite because then you can just change the way it behaves and it's not going to break everything else around it. If you can completely delete the old database, which is possible in some cases where there is nothing in the old database worth keeping, that was a situation for me. I think it was about 10 years ago. I rewrote an application that was basically running on computers. It wasn't on the internet even. It was running like inside a company network. And each time a machine died, there was no way to install it somewhere else. So like they didn't have the source code. There was literally nothing they could do. So they said, you know what, we're just going to declare bankruptcy on this application and we're going to write a new one. And it's going to be on the web. So it's going to be like this intranet and people will be able to access it from various countries also. So it doesn't have to be local. So it opened up a whole bunch of possibilities. So that was a good candidate for a full rewrite. But if that criteria is not met and you still for some reason need to do a full rewrite, I mean, it is still possible, but in any case, it's very good to bring in a team of people who are experienced in full rewrites. Or at the very least, if you have experienced developers in general at your company, then at the very least, bring somebody, at least for advice, somebody who is experienced in that, who can tell people, well, if you go in this direction, this is the pitfall that you're going to encounter. So be careful with that. So unknown unknowns, before you write a single line of code, you have to go digging. Look for the documentation. Maybe you have no documentation at all. Maybe you have too much documentation and very little relevance. It can be outdated or misleading, but it doesn't matter. Take the time to actually look at every document, even if you just skim it. Because even in the worst documentation, you might find a gem that can save you a whole bunch of time. So at least know what you have. Tests, you can have no tests, or people can say, we have tests, but maybe they're not runnable. If you try to execute them, they're just going to blow up. or they're going to not blow up but fail because the code has already changed and they never updated the test. So that is a very common scenario. Very rarely do I get tests that are actually working from my customers. Sometimes in C# I had a test suite that wouldn't even compile. So yeah, and they can also be very brittle, so it's very hard to move them to another environment because of some interdependencies. Like if you run them in a different order, they're going to blow up. If you're missing something on the internal network, it's going to blow up. So you have to take the time to analyze the test and see whether they're worth salvaging. And they can be in general unreliable. They can be passing, but the thing is, even if you delete the whole project, it might still be passing because they're passing because they were written in a way to pass and not in a way to verify the correctness of the application. So I've seen tests where people literally just assert true at the end. They don't do anything, they just assert true. They don't test anything at the end of the method. Dead code, also clean it up as soon as possible because it will slow you down if you have a bunch of unused endpoints. Have a customer with over 300 endpoints where 40% of them were either unused or abandoned. And so once we confirmed that they were unused and when cleaned it up, we actually saved a lot of effort. You can also have commented out code you should get rid of because if you're using Git, you don't need to comment out code. You can just refer to your history instead. You can have a bunch of unused classes or methods, but you have to be careful because even if your IDE does not flag them as flags them as unused, you might still have places where you do like a call user func and then call them by string, call the method by string, or just call them by a variable on an object, and you might not know that this method is still being used. So exercise caution. Also, you can have a bug repeated many times, so you have duplicated code, so deduplicate if possible. Unused variables don't seem like a big deal, but sometimes if you have a read-only operation and it's assigned to a variable that's not later used, and you remove that, and then you see that a whole bunch of other things suddenly become in use, and then you remove 90% of a method, and you're like, oh yay, actually now I can remove entire classes because though that code was relying on classes, and now those classes have no use. So you can delete a whole bunch of code if you start cleaning it up. So this kind of cleanup of that code should happen very early in the process. For testing approaches, and I'm nearly done, we'll have enough time for questions. The hardest part is actually not changing the code. It's ensuring that once you've changed it, everything still works at the end. And people sometimes think, when people think tests, they have been conditioned to think about unit tests, and unit tests are not the only types of tests. And in certain types of, especially when you deal with rewrites, unit tests are not necessarily useful because the classes might not even exist after your rewrites, or they might be completely changed. So those tests are going to fail anyway. So you have to write tests that basically will survive the migration. You need to write tests first that work, and when you've finished, those same tests can be executed against the new code and still work. And to do that, usually you would write higher level tests like acceptance tests. And if you're writing tests based on existing code, they're going to be called characterization tests. So characterization tests is when you don't really care how it behaves as long as you have a test to prove how it behaves. And then when you make changes, it still behaves the same. So they characterize how the application currently works with its pre-existing bugs if you have to. You can deal with the bugs later. So this is just what I do. Maybe you have a different approach. Maybe you know of a better way, and please share that with me. The way I do it is I have either Behat or Cypress, depending on the type of application that I have. If there's not much front-end JavaScript to worry about, I would usually go for Behat. If I have a lot of UI, then Cypress. So you can write characterization tests, and that would work for all the new versions of the application. And then you fix the code, and then you write unit tests for the fixed code, or at the very least, any new or refactored code and whatever things that you thought you fixed well, but then failed. So you're going to have to write a test to make sure that you actually fixed it well. So this is the order in which I do the version upgrades. The slides are going to be available after the talk, so you don't have to worry about remembering the order. For new frameworks, essentially the same thing, characterization tests first, that should survive the migration. Then you migrate, and then if you wrote any new code or refactor existing code, and if you had any end-to-end failures, when I say end-to-end, that's like the staging server. You will, if you take care of mostly move code across controllers, then you shouldn't have to worry too much about unit testing every single thing. That is something you can do later after some more refactoring. Progressive rewrite, slightly different. You would write unit tests for the new code before you write it, because if you want to swap out the component, it's going to be new code, so might as well write the unit test for it first. But the characterization tests are still necessary. And then you write a new code, which will pass those unit tests and the characterization tests. For refactoring, it's the same as the previous one. Unit tests first, because you're for the upcoming code that you're going to be writing. So if you're taking a class and splitting it into two classes, those two classes need to have tests for them. And then you write that. Very quickly about the environments, it's very important to have proper local and staging environments. I would usually recommend to use Docker, even if it's a bit of a learning curve, it's really worth the effort. What you would do is you have two images, like the baseline and the migration, because at any point in time, you want to see how it used to work and how it works now to compare and to see where you made the mistake, and also be able to put breakpoints and really have them side by side to make sure that you make a sound transition. And you know, how do you determine how to set up this image? Well, you are going to look at any place where the application currently runs successfully, either the production server, or if there's a vagrant, or if there's an XAMPP setup, whatever, just analyze that. And so this is an example of a Docker where you would have the PHP baseline and PHP migration, then the database baseline and database migration, and then the acceptance tests are going to be completely separate application. Some of the gotchas, pay attention to MySQL mode in like full table joins and things like that. The defaults are different in newer MySQL versions. And so you might end up, or what you install from the Docker image might be different from what you have running. And so the same queries are actually going to behave differently based on the mode. Run Composer inside Docker, not inside of your local machine, because then it will log the right versions based on the version that you want to run, so that it installs things for PHP 5 or PHP 7 and not whatever you have in your machine. For the production database, you probably want to anonymize it and grab it from there and run against a real database instead of creating your own database content, because your own might not have all the weird, missing foreign keys and stuff. So you might make too many assumptions. So just take whatever is running in production and then just anonymize it by removing, customer names and emails and addresses and anything that is dangerous. Like I'm working with an application that has a whole things about law enforcement. So you cannot have that on your machine, just don't. And then if you have any emails, send them to a relay, such as debug mail or mail trap. Basically make sure that no actual emails ever leave your machine or even your staging server. And yeah, for the staging server, which is where you'll be testing things in the browser, somebody who will manually go through it at least once. You'll also have a baseline and a migration server to compare the behavior, and any configuration, again, pointed to sandboxes, like don't process actual payments, don't log in against the real LDAP, don't put things on the real FTP because then it gets picked up by some third party, etc. And that is it. I had to zoom through it. So yeah, this is it about rewriting legacy code, and I will take your questions.
Okay, thank you, Anna. I will try to relay a couple of them to you. To be fair, you covered a couple of them while going through the talk. For example, someone named Rector as a possible tool. And the first meaningful question is, can PHP Storm refactor the whole code base at once, not just the current file?
Oh, yes. So the way PHP Storm works, and I love this about it, this is why I'm more and more favoring PHP Storm as a refactoring tool for me. So you can take a class, you can select the quick fix, but you can also tell it, like you can go to the submenu and you can tell it to run it on the entire project. And it's going to find all of the occurrences of this problem. And you can select the whole thing in the window where it finds all the occurrences, and you can just mass fix everything. It's just going to be for a very long code review after that.
Yeah, probably, yeah. But it's really, really helpful, I imagine.
Yeah. As I said, 67,000 lines of code migrated at once.
Yeah.
that's just one inspection.
Whoa. Yeah.
Yeah, because there are other things to migrate. Yeah.
Yeah. No, I can understand. The next question is, can you suggest any technique on how to estimate the work needed to rewrite a legacy project?
Oh my goodness. So I have a not very controversial opinion about estimates. It is extremely difficult to estimate. To be fair, any estimate that anyone does for refactoring is probably going to be wrong, which is why I recommend splitting it up into a smaller scope and just do it at once and just get it over with. But I can give you an example. So I had a client with 4 million lines of code that took 6 months just to upgrade to the newest PHP version. So it was, well, we didn't freeze the development for this one, but we did have to deal with all the merges afterwards. But yeah, it was a lot of work. Another project where we switched from one framework to another, that was, I think, something like 500,000 lines of code. But because switching frameworks is a lot more involved, that took about 4.5 months. And that was with the automation.
Wow. Still a lot of work then.
Yeah, this is why most people say, well, if I'm going to be doing this for 2 years, might as well rewrite everything. But yeah, like automation is going to be your friend.
Yeah, sure. Well, I participated in something like that, but it wasn't outsourced. We did it in-house. We basically had to switch from Symfony 1 to Symfony 2, which is basically a full rewrite. And we did a continuous rewrite, but we basically avoided freezing development, and we basically had two projects, one on the side of the other, but we did it so slow that at the end we basically took it for 2-3 years maybe, because we basically we were doing piece by piece and replacing, as you suggested, endpoint by endpoint or feature by feature. And we reached a point where basically we didn't care about the fact that we had some legacy in one angle. Basically, we were left behind with one feature that nobody touched, and user management. And I just did it the next summer in August, where everyone was on vacation and the business wasn't on top of us. And so we did, okay, that's the time to put the plug, and that was the end of it. But it took nearly 3 years, because basically what I've learned is that normally the main issue is that the client or the business will still ask new features in the meantime. Yeah. So you cannot keep up with both at the same time. You cannot write the feature on the old project and at the same time migrate it in the new project. So normally we answer with, okay, this is big enough. Let's write it completely on the new project and use the occasion to fix and improve what we had on the old one. And that's the biggest selling point that we had with that approach, with that strategy.
Yeah. Progressive rewrites are a very good strategy when you have this continuous projects. Very good.
Also, we started writing tests on the new one, so that was a big plus too.
Yeah, that was the big plus. And then later you can refactor your codes. And I'm hoping to prepare another talk. I just got the idea yesterday. Hopefully I'll prepare another talk where I will discuss how to create your new code so that it doesn't rely on the frameworks as much, so that this exercise becomes much easier in the future. I mean, those techniques already exist. It's just I want to be able to summarize them and present it in a coherent way. So hopefully hopefully a talk next year about this.
Yeah, we'll see. Okay, let's try to see if we are able to answer a couple of more questions. Roberto asks, someone suggests creating an SDK for every single functionality to refactor. First the simple parts, then the complex parts, and finally the core of the application. What do you think of this approach?
I'm not sure what the person means by an SDK. Is that like rectors or
no, I think they mean like rewriting the feature in a small library or in a small part of code that is extracted from the old code, probably.
Yeah, and this is basically, fits either within the progressive rewrites or the refactoring strategy. So yes, you can extract certain functionality, put it, in a clean component, and then rewire everything to point to that component instead. I like this idea very much.
Okay. Then there's a question that you cover about test approach. You get that in the last section. Davide asks, I'm in a situation where the data model has changed a lot, but the database schema has not kept up properly. Fixing the database will require a ton of code changes. Would that justify a full rewrite?
Let me think for a second. So there's a model that is mapped on the database, and the database hasn't kept up with the model.
Yeah, basically they didn't touch to match it.
Yeah, I'm just not quite sure how the model works on the old database. Then what exactly is the challenge? Maybe I'll go to Hopin afterwards, and maybe I'll get some more information. Sounds like a very specific use case.
Yeah, probably depends how they map it to the database. What abstraction do they have to do that? Probably.
Yeah, I'll be available on Hopin for the next half hour or so we'll be able to chat.
Next question it's from Marco Perone. Did you ever try quickstorm.io? I don't know that tool. I don't know if you do.
No, I don't, but I will write it down and I will explore it because now I'm very intrigued.
Okay.
How do you spell it?
Quickstorm, sorry, STR. I didn't.
Okay, quickstorm.io.
Looks like a typo for storm.
Okay, I'll check it out.
Then we have a question from Nicola. Have you seen at least one case where rebuild from scratch is faster, better than refactor? When is the correct step planning first phases to understand if it's better to do a project from scratch? Well, I think you partially covered it in the talk.
Yeah. I mean, it depends on the constraints. It depends on the experience and the size of the team. If you have like a team that basically has nothing to do for a certain period of time, that's probably going to be faster and cheaper. The size of the application, again, how ingrained it is with other applications within the company. But if it's just like a isolated application, nobody else uses it, it's just like a standalone, and it's fairly small, then yes, sometimes doing a rewrite is faster. It's a bit like the trade-off between automation and just doing it manually. How long does it take you to automate something versus how long it takes you to just do it manually once? So it's about the same sort of approach to weighing the pros and cons, I would say.
Yeah, there's a famous SKCD drawing about that with the graph.
It has like 25 lines. Yeah, it's a big table.
Yeah. Okay, last one is from Ryan. What do you recommend as an approach for finding unused endpoints?
Finding unused endpoints? So it really depends. So one way to do it is, like, for example, if you use a Zen Framework 1, right, you know that the method ends in action, the method name. So it's a public method and it has action at the end. So you can just go and automatically inject a logger that's going to log all of these, and then you just let it run in production and see which ones are unused. So this is a very generic way to do that with any sort of framework. But you can also analyze the code. Like what I did is for the current client is we scanned all the endpoints and then I stick them in the browser. And if it fails because a view is missing, then we're like, oh, maybe this one is missing. It's a bit tedious because they have 1,500 endpoints. So it's
yeah, that's a lot. That's a lot.
Yeah.
Okay, I think we're fine. Thank you again, Anna, for your talk, and see you. And as I said, you're available on Oppin, so if you want to ask
I'll go
more
through the
stuff to
hallway
Anna.
track.
Okay, perfect. You can find it there. We have a brief break for now, and so I see you later in a couple of minutes.
Okay, thank you very much. Thanks for having me.
Thank you.
Have a good day, everyone.